Hello, everyone. I'd like to introduce Dr. Snyder. Dr. Snyder, for the audience that doesn't know you, please introduce yourself.
Hi, I'm Mike Snyder. I chair the genetics department at Stanford School of Medicine. I also direct the Center for Genomics and Personalized Medicine.
So my first question to you would be, what fascinates you even to this day with your research?
Well, everything. We're pretty broad, meaning, I get excited by pretty much any biological problem, but our research these days is really focused on wellness. We're trying to transform the healthcare system from being sick care into truly healthcare, meaning let's keep people healthy so they live long, healthy lives rather than treat them once they get ill. So that's been the big focus of our work and drives a lot of what we do.
Is there anything in particular that you kind of find hopeful when it comes to the future and like research that you've done recently?
Oh, yeah. I mean, I think we're very much going to do what I just said, but it's going to be a combination of things. One is the ability to collect very, very deep data on people. So we can now sequence their DNA and make predictions about genetic risk. We can measure thousands and thousands of molecules out of people's blood, and that's something we've been pioneering. And also out of urine. We study, believe it or not, your poop and your microbiome to see, which has important health consequences. And the latest thing we've been doing is a lot with wearables. So smart watches, you can see we can talk about that. My watches, my ring, they all sense you 24/7. So we've been able to show you can catch disease early with these things. And the last thing is we can take little drops of blood from people in their house. They mail them to us, and we can measure thousands of molecules, which actually have important health implications. So we do a combination of different technologies to get a deep dive on people's health, and a lot of it can be done in their own home, which I think is going to transform the way we do healthcare.
I have a smartwatch myself, so let me ask you this: when it comes to like what it can and can't measure, right? Because I remember Fitbit a few years ago had kind of like this, not scandal, but like issue where, they issued a statement saying like, this is just for fun. Don't use this as like a super, as like a medical tool, right? So now, like, with Apple Watches and stuff, it can measure my sleep, the amount of REM I get, like, all this sort of data. So like, how useful is it for like a predictor, or just a measurement tool for someone's health?
Some areas are really, really good, and some areas still need a lot of improvement. Areas that are good, your resting heart rate's actually quite good. Something called heart rate variability. Believe it or not, you're supposed to have a variable heart rate, meaning because it has to do with how your neurons are called parasympathetic neurons interface your physiology. So you're supposed to have, and most people do, and they're quite accurate actually from a smartwatch. Almost any watch will give you accurate measurements. Certain things like blood oxygen you can also get from a smartwatch, and the accuracy varies a lot from person to person, especially people with dark skin have a hard time getting accurate measurements. But the deltas are fine, meaning you can still see changes in people's blood oxygen with these devices. And that's really powerful. So we think even in cases where they may not be so accurate, measuring these changes is what's going to be important. As far as being FDA approved, they are for certain applications. That's happened recently, as you point out, but not others. And I think that'll just take time. It's a brand new area, but it'll come. Nonetheless, they're still pretty valuable. And you mentioned sleep, which is a super valuable thing to measure. Most people don't get enough sleep. And the devices are pretty good for sleep duration, something called restlessness, like how much you toss and turn, and latency, how long it takes you to fall asleep. They're pretty good for that. Not very good for something called REM and deep sleep and light sleep. They're not very good for that. But nonetheless, they're pretty good for some of the major things you should be doing, like sleeping more and knowing the quality of your sleep. That's a big deal, we think. So I think the smartwatches are going to be super powerful for measuring people's health. Now, it's true that the companies don't want to call them medical devices just yet because that has strong implications, meaning if you call something a medical device and gives recommendations, that takes it to a whole new level. But just as what we call wellness tools, following like basic things, They're pretty powerful for that, and they will be forever. What our biggest thing is we showed you can detect infectious disease when people are getting, in my case, Lyme disease. I actually picked it up first with a smartwatch and a pulse ox, something to measure your blood oxygen. Now we've shown that you can tell when people are getting respiratory viral infections, including COVID, in advance of symptoms from a smartwatch. So I think these devices are going to be super, super powerful. And right now, they're just being used in research studies and tests, but someday they'll be used actually as approved, modified tests, I believe.
So, in terms of, for example, calories, right? How accurate would calories be?
That's so. They're measuring your steps, they're measuring your heart rate, and then they derive how many calories you're burning. I think it's okay, but not great. It's use that as a rough approximation. Same with VO2 max. I think it's sort of okay, that you can get from your watch. It's not as good as what you're going to measure in a clinic. So some areas they need improvement. Skin temperature, that depends a lot on the devices. Some devices are really good, some not so good. But there's other things they measure that you don't even measure in a doctor's office, something called galvanic stress response, meaning conductance on your skin. That actually is an indication of skin dryness, and it can be indicative of stress, diabetes, all kinds of things. So you can actually get some pretty useful information from a smartwatch you don't even get in a doctor's office today.
So they're pretty good for everyday use, but they wouldn't, they shouldn't be used as the end all be all for medical advice.
No, I think you use them as an indicator, kind of like the way I view it, it's like your car. Your car has lots of sensors on it, and it relays it back to your dashboard, tells you something's up, and then you go get it checked out. That's how I see these devices. They sort of say something's off, and then you go dive a little deeper and see if it's really a big deal or not. But they're really, because they're measuring you 24/7, they're really following you all the time, so they can track your health much, much better than what you're doing right now. So that's why we think they're powerful. We think for COVID, if you go jump up as little as 2 beats per minute in your resting heart rate, we'll pick that up, and we can send you a red alert that says something's up, and you may want to get it checked out.
Well, I remember personally, I think I started like running and doing more cardio, and I got a notification from my watch or my phone, because I was wearing the watch more often, that my resting heart rate like lowered by 10 beats per minute within like the span of only 3 months, which was really incredible. So is like that's like an example of like what you're talking about, correct? Where it can measure.
Did yours lower because you trained more and improved?
Yeah, because I
Yeah.
was running. I was doing like
Yeah.
running every day.
Yeah, so you were using it, yeah, in that case to show you're improving your basically health by getting in shape. Yep. Yeah, absolutely. We're using it more for the flip side, early disease detection. But you can use it both ways, exactly like you're saying. It gives you a good indicator, your resting heart rate. Check out your heart rate variability, see if that's improved too. I'll bet it has.
I think it did at the time. So did my VO2 max by like 2 points or something.
Nice. Okay.
That was like last year, but it was still really interesting to me when I got that notification.
Sure.
Like,
It's
10
not
beats
that
per
easy.
minute. Yeah.
Yeah, it's not easy to improve your VO2 max. So well done.
I appreciate that. This is also just a side question, but I saw a picture of you and Joe Biden recently. What was that about?
Oh, that was a long time ago. That was back when he was vice president. He came to a meeting I was at. I was president of it's called the Proteomic Society, where we study lots of proteins. And he came as a speaker. It was really nice of him. And yeah, we met him and had dinner, and it was really a lot of fun.
Any comments? Nice guy or?
Oh, he is. Yeah, super nice guy. Had important things to say. Yeah, it was really a pleasurable experience. Yeah. So he's bright. There's a reason he's president of the United States. He's a smart guy, and I think he's doing great. So, and certainly when I met him, yeah, he was very engaging. It was a lot of fun.
It's good. That's always good to hear. Yeah, no, I just saw it and it was like, oh, that's really interesting. I should ask him about that.
Well, someone
Um,
else, then later he became president. Someone took the picture and posted it up on the website. So,
yeah, it just seemed very recent, but
yeah,
yeah,
probably
no,
not. This happens. Yeah, I happened to meet for whatever reasons the president of India. His name is Modi, and someone threw that up there recently.
that's good. That's really good. So let me ask you about in
By the
terms
way, by the way,
right.
it goes to show that everybody cares about their health, even presidents.
Well, they should. They should. Health
They
first, always.
should. They
Nothing
should.
else in the world matters if you're dead, you
Look,
know?
the guy's doing great at 80 years old, right? So pretty amazing. We
Yeah,
want to be doing that well when we're 80, right? We're
right.
probably even do better because I think we're better at taking care of ourselves now than we were, 40 years ago.
That's absolutely true. So let me ask you about something very simple, allergies. So it's something that kind of goes into your expertise in genetics. So my dad, and it's like I'm using myself as an example. My dad is allergic to birds and cats, right? And as a kid, I was allergic to cats very severely. Now I'm allergic to cats, probably lesser than he is, but I'm not allergic to birds. Why is that?
Yeah, I don't know the answer. The whole allergy business is still very mysterious, and it's not my area of expertise. I follow a little bit. I myself have certain allergies, and allergies come and go. So, A, you are predisposed to them, meaning there is genetics behind it that can predispose you to them. B, there's no question it's how you interact with your environment. And you may know now people are a lot more allergic to peanuts. Many more people are allergic to peanuts, for example, than they were 40 years ago. And a lot of this has to do with exposure. Some of it's so a lot of it's due to the environment, not just genetics. And there's some very interesting studies where they had people in the same general location. Some were on farms and some were in the city. And the kids that were raised on farms had less allergies than the kids that were in cities. And the idea is that they were getting exposed to more dirt, more environmental things that actually helped train them not to be allergic. Whereas the kids in the city got more allergies and asthma. And so the idea is that rolling around the dirt a lot when you're a kid is pretty good. You may have done that anyway, may have still gotten it because you probably genetically predisposed, but it's thought that we're being overly clean now in many cases, and that's the cause of it. But exactly why people are allergic to certain things versus others isn't so clear. Probably part of it just has to do with how your immune system got trained. A lot of that happens in the first 3 years of life, believe it or not. But allergies are very mysterious. They come and go. Like I was not allergic to anything until, I don't know, in my 20s when suddenly I became allergic to pine and eucalyptus, it turns out, which I had not been aware of. And it came, then it got kind of bad, and then it kind of just gradually went away. And so there is a strong environmental component. These days, believe it or not, you can train kids off of allergies. You give them tiny little doses of what makes them allergic, but very, very small doses, and gradually increase it. And it keeps away the allergies. It's pretty amazing. And so that's been a big thing that's out there now for trying to wean people off of allergies. I don't know if it would work for you, George, but it could be worth a shot. Do it
Well,
with
I
a
mean, I'm not
do it with a doctor, though. Don't do it.
yeah.
Make sure because you can't afford to go into prophylactic shock, right? That would be a disaster.
Right. Well, I mean, I'm not that allergic. It's
Oh,
like,
good.
it's just like sneezing, like itchy eyes, but
Okay, yeah,
yeah.
yeah,
But like, it's still a pain. Like, if I pet a cat and I rub my eyes, I'm gonna be itching it for the next like 3 hours. It's gonna be annoying.
yeah. You probably need to take antihistamines then before you pet the cat next time.
Yeah. I mean, it's not like I own one, so it's not too big a deal. But
Good.
but yeah, no, it's just something I always kind of found fascinating about, my dad has it.
Yeah,
I kind
yeah.
of grew out of it. Like, it's nowhere near as bad as like when I was a kid, you know,
Okay.
because when
Yeah,
I was a kid, it was like more wheezing. But yeah,
yeah, yeah. So maybe it'll keep heading in that direction. Yeah, your whole immune system, how these things come and go, these allergic responses is tricky. Yeah, I myself have had my share. Yeah.
so going back to what we were talking about with personal fitness, but also kind of the same topic of genetics. When it comes to working out, why is it that some people can be in the gym for like 5 years and they can look pretty good, but then some guy can only be in there for 9 months, right? And look like a supermodel, right? Like look like the same guy.
Yeah.
And like they started out at the same level, right? So like a lot of people always kind of blame themselves. They're like, oh, it's because of my genetics. I can't look like this guy. I can't look like that guy. What's your take on it?
Well, again, there's no question genetics. There is a genetic predisposition to everything. Your looks, your behavior, your personality. There's a genetic component. When it comes to lifespan, believe it or not, your genetics only accounts for 16% of how long you'll live. It's really environmental factors, the food you eat, sleep, exercise. What I think is interesting as a researcher, the things we do the most, we know the least. Like how does sleep really work? How does the food you eat really affect your health? We know certain foods are healthy for you and others not. We don't know all the ins and outs of why that is. We know too much sugar is bad for you for obvious reasons, but most of the other stuff, like all the vitamins, the antioxidants, how does that stuff all really work? And same with exercise. So we don't really know exactly. It's pretty clear exercise burns off, excess glucose, excess fat, and some people respond really, really well. Again, a lot of that's trained probably a bit early in life, how you've set up your whole, if you will, metabolic state. We like to say your metabolism is very intricately woven with everything: your fat, your health, your metabolic, your immune system. And so we're all wired a little bit differently, probably, again, how we got the food we've gotten exposed to the various things. And probably exercise early in life. So I have no answer for what you just said. Why some people look like, say models and others don't seem to improve so much. Definitely a higher intensity fat exercise is thought to be helpful. Generally, the word on the street, if you will, current is that strength training is important for building your muscle mass, for all kinds of glucose homeostasis, but also some level of cardio for keeping your heart in good shape. That combination is thought to be really good. It used to be people kind of ignored strength training, believe it or not. You heard about runners. Everybody's a runner and they're doing lots of running and ignoring strength training. Well, that probably is okay for certain things, but what it's lacking, it doesn't build muscle mass, which is really a big deal, especially as you get later in life. You're pretty young, George, but as you get later in life, people get something called sarcopenia, where their muscle mass, goes down basically each year. You lose about 2% per year as you get older. And that winds up, if somebody starts becoming immobile when they're older, their health just plummets. And so I think keeping your muscle mass up and starting at a young age is probably really, really good thing to do. Probably, helps but add some cardio. That'll probably help keep you in a little better shape. I'm not going to tell you it's going to make you a supermodel, but hopefully it'll help, give you some good physique. It'll certainly improve your VO2 max and make you feel better.
Yeah. Well, and this is also part of cardio and tying that with genetics. A friend of mine, I remember, and I don't know how true this is, but there's a kid that I know who is kind of like on the bigger side and he runs, right? But he kind of seems like, and he's not like big, like fat. He's like muscular, but like no matter how much he runs, his cardio doesn't seem to improve vastly, right? In ratio to like, maybe smaller people. And my friend was like, oh, well, that could be a genetic thing, right? It's not necessarily a weight thing. I thought about that. I'm like, well, maybe. So would my friend be correct in saying that's a genetic thing, that some people just are naturally, no matter how much they run? Like, for example, I think Conor McGregor, like he obviously he's training and running all day, but he gets gassed pretty easily, right, in certain fights. So, why is that people are training for hours and hours on end? You can't say they're being lazy. They're training all day and all night.
Right.
And yet their cardio seems to not really either improve like ratio to other people or just in general.
Yeah, I mean, maybe it is genetic. Maybe it's just how their proportions have gotten established early in life. Yeah, I'm not so sure. And also maybe different kinds of training or better for some people than others. So there's high intensity training, sprinters. There's a project we're doing now to try and see what's better, sprinters or endurance running, for improving your VO2 max. People don't really know the answer to that, interestingly enough. There has always been an emphasis on, say, doing, endurance running, or at least middle distance running. Yet a lot of people think sprinters are actually better for cardio training. And maybe for him, maybe cardio training, maybe intense sprints is better than long distance running. I'm not sure what form of running he's doing. But I do think matching your exercise with your body physique and shape is probably going to be a big deal in the future, because again, we're all built a little bit differently, and we probably have different performance characteristics across different parts of our body. And I doubt that anyone's really worked out the formulas for that. It's something our lab's pretty interested in, believe it or not. So it just hasn't been studied. It's a great question though, George.
Yeah, because like even for me, my like I just don't naturally have good cardio, right? But I mean, I practice it, right, and I do get like pretty good, with training and stuff. I like last year, I was only able to run like a mile and a half, maybe at most. Now I can probably run like that pretty easily, right?
Okay.
It's a matter of just practice for me more than anything. But when it comes to like I guess like for me, for example, like as a kid, I never really did cardio. I never like ran around too much. So is that part of it, or?
Probably, yeah. Probably how much you trained early in life. Yeah, it's going to be a big factor for both your probably your mental stimulation for wanting to do this, but also your physique as well. But a lot of people become runners late in life, so you've got plenty of time ahead of you to become a marathon runner if you want to. I'm not saying you should become a marathon runner, by the way. Marathon runners, they don't live longer. They actually live kind of average, and some die young even, probably because it's too much stress. So there's a matter of what's right, what's reasonable, but people run these triathlon, these overperformers don't really live as long as, say, people who are just generally really fit. So there is a limit to how far you should push yourself.
I have heard about that. So, but why does that happen though? Because everybody says there's a lot of stress on the heart, but what specifically is happening to the heart? Because the way I see it is, if I train myself, and I'm getting like, and I have good cardio, I feel a lot better, right? And I feel like, not much is like a struggle when it comes to like cardiovascular wise. Like I have more energy throughout the day. So why is it that if I become a marathon runner, that's evening out basically, and it's like I'm living more or less the same amount as somebody who doesn't run or only runs like a few miles every day?
Yeah, one is, I think you do wear out your joints. So running really does pound your knees. It's usually the first thing to go in runners when they hit their 40s or 50s. Their knees become sore and they become arthritic because you're actually banging and wearing down your cartilage in your knees, and it's pretty tough on them. Interestingly enough, I was a runner until about 7.5 years ago. I ran a lot, and it reached a point. I'm in my 60s now, but when I reached a point where when I got out of bed, my knees would be sore. I'd hobble down the steps. It was really quite agonizing a little bit. And then I switched to weightlifting, believe it or not. You can't tell, but I actually do lift weights. I gained 10 pounds of muscle mass over a year and whatever. And basically, it's counterintuitive. I thought, using heavy weights, and I'm doing squats and things which are tough on you, which I thought would be tough on your knees. Believe it or not, it cleared it right up. All the pain in my knees went right away. So what's happening is you're strengthening your muscle mass around your knees. And it really suddenly, all that stuff that used to be sore just disappeared. So I actually think just running by itself was putting too much pressure on certain joints. Say the same thing about basketball players, you hear about football players too, with certain joints because of there there's contact issues on the head as well. But yeah, you can become arthritic because you're overly stressing certain parts of your body. And so I think having a balanced exercise, I do think strength training is a big deal, and resistance training, as they say, for strengthening all your muscles and then giving better control. So for me, I've been weightlifting, as I say, for almost 7.5 years, and I don't have any of these issues I had, before all this that were quite, I thought, yeah, affecting, my physique and lifestyle. And so one of the good things you get when you mentioned this earlier, why do you feel good after running? Well, you release all these endorphins. Same is true for weight training and stuff. When you push yourself, you get a good workout, you wind up releasing a lot of molecules from your muscle, endorphins from different parts of your body. But they give you a positive, they give you a warm, good feeling. And so that's an advantage of exercise. It helps stimulate a lot of these things that are good for you. Some of these other hormones that get stimulated from your muscle by exercising, they really keep your body and your brain fit in a lot of different ways. So exercise has many, many different, positive advantages. And we don't fully know, again, somebody like me wants to understand all the molecules and circuitry that makes this stuff happen. We don't really know that. We only know a few of the key molecules. There's many, many more to study because a lot of people say, well, in the future, I'd rather just take a pill and not have to run at all. So we're a long ways from that. Keep your running up, George.
Yeah, we'll do that. But this actually brings me to something that, I think he's professor at your university, Andrew Huberman.
Yeah.
Has spoken about. Well, do you know Andrew personally, or?
We've communicated a number of times. Yeah.
That's good. How is he?
Oh, he's great. Yeah, he's very, very sharp. His podcasts, there's a reason he's very popular. He's a great, he's a very smart guy, lots of knowledgeable and lots of down to earth advice and information, stuff people really want to know. Great communicator, of course. So yeah, terrific guy.
Yeah, that's what I've heard. He's over. I love his podcast.
Yeah, well, there you go. Maybe you'll rack up as many numbers as he does. I don't know how. Well, you may have a lot already. I'm not so sure. I just don't know.
Yeah, maybe one day. But what's it called? With regards to something he's spoken about willpower and the study of it and how it works. And I know this is entirely your department, but is willpower and motivation at all genetic, or is there any, how can a person naturally, or through anything, how can they develop stronger willpower? Because there's some people that just have, as soon as they wake up, they have the will to do everything, get everything done. You get a guy like Mark Cuban, for example. He wakes up, goes on an exercise bike, does this, does that, reads emails. But then there's some people that don't feel like doing anything all day. And, that's just the way they are. And they might be happy like that. I don't know. But why is it that some people are like that and others have all the motivation in the world?
Yeah, well, you are out of my area of expertise. It's true. But it's clear getting a good routine going is number one. Get yourself going. And then if you can, once you get started, keeping that routine up, it's pretty easy to do. It's the hard part's getting it started. And so develop a very specific routine. Get your day organized. Everyone will tell you this is the best way to stay disciplined. So, for some people, most people, it's making a list at night before the next day. So they get up and they know exactly what they're going to do. And speaking for myself, I've shifted to this weightlifting, I say, and I pretty much do it every day for the last 7.5 years. I rarely miss. I only miss if I'm traveling or something like that. So you really have to discipline yourself. I think there's no question that there are feedback control mechanisms and all this. Like if I do miss a day of exercise, I notice it. I can really feel it. But there's also, like when it comes to drug addiction and stuff, there's opioid receptors in your brain, for example, really need to be stimulated for heroin addicts and things like that. So you've got to train yourself off of these sort of neural circuits if you go down a bad path. But I think the same thing is true for when you go down a good path. You're stimulating, your neural circuitry to want to do these things and keep up the pace and make it all happen. So I'd say, it's you got just getting started, getting yourself organized, and then off you go.
So, and that you actually reminded me of a question I've wanted to ask you, or just somebody in genetics, right, as a whole. So, in terms of addiction, right, and people's addictive propensities, I take psychology right now, and we looked at all like the twin studies experiments where they showed how, like nature versus nurture, where a lot of things, like I think 60% of your personality is genetic, but a lot of it's also environmental. And a lot of people have, certain propensities for certain addictions and addictive personalities. How does that exactly work? Like, why is it that some people have such a heavy propensity and like let's just say their dad was an alcoholic and then their mom, like taking pills, for example, that person is more likely to be born with a propensity towards addiction. Like, why is that? How does that work?
Yeah, it's a great question. The answer is we don't know. How the genetics of behavior is so poorly understood. It's an area that's kind of hot these days for people to study. So it is being studied more, but the number of genes, even most of these things turn out they're what are called complex traits. No single gene is responsible for this. So that means mapping out the genetics is very, very hard. Even simple things like diabetes, you'd think would be easy. Mapping out the genetics of diabetes has turned out to be pretty hard. We have now 200 genes that have been identified and explains maybe 18% of the genetics that's there. We still have a lot more to discover. When it comes to behavior, that's even harder, people, especially addictive behavior and things. So there are some genes that have been identified, but how the whole thing works is not so clear. But probably a lot of it is going to work into brain circuitry, as you say. So how your brain, different people express their genes differently, and so that does affect their behavior and such. We had a study out recently where there's something called severe COVID. So older people get severe COVID and die because that's their immune system's gotten worse. But young people get severe COVID and can die or wind up in a hospital. And that's thought to be largely genetics. And we've worked out some of the genetics behind that. It's pretty complicated with some new AI methods and found over 1,000 genes. And we can explain a lot of the genetics, but we still are missing a lot. And we don't fully understand how it works. So it's even more complicated with behavior, especially in part because this gets technical, but knowing how to quantify people's behavior is a big deal. If you can measure it, then you can better study it. When you're just sort of, they're addicted or not addicted. What does that mean? If you quantify that better, you can better study it. I don't know if that helps, but the bottom line is we honestly don't know. You're asking great questions. We don't know how a lot of the stuff works. Yeah. And it'd be fantastic to learn that.
Well, if there was any, and this is part of the genetics, topic that we're going down. It's about in terms of heritable diseases, right? Like diseases that you can I assume measure, right, in some way how heritable they are, right? So you get a disease like something really horrible like cancer, right? Let's just say lung cancer. So, and you have this family history, like let's say dad died of lung cancer, your mom, had stage 1, recovered, or, something like that. And it just keeps going up the family tree. Why are you going to have it, basically, is what I'm asking. Like, are you more likely to have it or?
Yeah. So the answer is you are. Let's start. We'll go do a little background in genetics. Genetics, there are single gene mutations that can put you at really, really high risk. And the classic example is, have you heard of BRCA mutations and putting women at risk for breast and ovarian cancer? It's when women have, when their families with breast cancer running in them, they're often, but not always, due to BRCA mutations. There's a single gene mutation to put you very, very high risk. And there is a lot of that. Same with some heart disease risk genes as well. So there are these single gene mutations, and those are relatively easy to identify. And depending on the nature of that mutation, you either have, 50-50 chance of inheriting that, or one out of four if it's what's called a recessive mutation. So the single gene mutations, they're very easy to spot. You can follow them, and it works. But then there's a complex disease, which I was alluding to earlier, things like diabetes, coronary artery disease. Most diseases are complex diseases. They're not thought to be due to single gene changes. They're thought to be due to literally hundreds, if not thousands, of changes in you. And if you inherit the so-called bad changes, you'll wind up at higher risk. And if you get the more protective changes, you wind up at low risk. And so that's just luck of the draw how those genes segregate. But in general, through your family, but in general, if your mom and dad are at higher risk, there's a good chance you'll be at higher risk. We're good at finding these single gene mutations. We're not very good at this complex disease stuff. And that's what a lot of people, including our lab, are working on as well. I think there are new methods out there for being able to tease that out.
Well, yeah, go on.
I know you're hoping for, more definitive answers, and we will get there someday. We're just not there yet. We just need more sophisticated studies, and it's one thing that our lab is working on. And as a good example, ALS, which you may have heard of, very debilitating disease, and it's Lou Gehrig's disease, and basically, when people get it, they die within a few years when it's first diagnosed. But there's no prediction for that yet. It's known to be highly genetic. It's something like 61% of this disease is thought to be due to genetics. And basically, there have been some studies done where, using traditional methods, they found 7 genes responsible, but it only accounted for 6% of the heritability. We went in with some new artificial intelligence methods and actually found now 700 genes that are involved in ALS. And we're trying to get to making predictive risk scores so you can predict whether you're going to get ALS or not. Now, that could get a little controversial because even if you can predict it, there may be a limit to what you can do about it so far. We don't have good treatments for ALS. So people, when they're diagnosed, but other areas like something called abdominal aortic aneurysm, this is when people's aorta bursts and they die. That one's usually discovered when that just happens. People's aorta bursts and they die. So we have come up with new methods for being able to dissect that. And so I've found a lot of genes are now involved in that. We can make predictions on who's at risk. And so we can track people better now as a consequence of this. So we think this is really, really important. And so I think we're getting there to be able to better understand and diagnose disease, but we still have a long ways to go. So get ready. Someday we hope to predict the right best exercise for you, the best, what you're at risk for genetic diseases, all that sort of stuff.
Well, it's funny that you say that because my follow-up question was going to be about CRISPR and, gene editing in the future. Now, I have, just in general, right off the bat, what are your feelings? What are your thoughts? What do you know about it?
Yeah, we know a lot. It's done in the lab routinely. It's a very common research tool that people use. Our lab does a lot of it. As far as fixing people, initially it will start out by fixing people with blood diseases, because what you can do is if somebody, and it's being used now for sickle cell, it's being used for other things, where people have these blood diseases, you can pull out what are called their stem cells. The the cells that'll make their blood cells. You can pull those out from the person, make the change, and put them back in. And because it's all done in the adult, there's no chance you're going to make some weird genetic mutation that's going to wind up in their kid or future generations. So it's a very doable thing for solving diseases in adults. And so it's just starting. There's hundreds of trials out now using CRISPR to try to fix diseases. And some it's going to be, it's going to work, and it already is working at some level. So I don't think anybody's going to have a problem fixing genetic diseases with CRISPR. And as I say, the key is to make it safe. Some of the early gene therapy things, when they tried them, they actually, turns out they made changes, but then secondary changes came up that actually killed the person. So it's very important to make sure you understand how, get it working right, so that, yes, you fix problem A, but you don't cause problem B. So anyway, I think with the adult stuff we're talking about, it's a no-brainer, especially life-threatening diseases, to make these changes. So I think the more controversial areas, what do you do about what I call enhancement traits? Trying to make someone a faster runner, making someone a smarter person, whatever that means. Yeah, and we don't know enough about genetics to do that. B, it won't be single changes you make to make that happen. You'll need, you'll have to make multiple ones. So we're still many years away because our understanding is very limited. But there's some things that'll be a little bit closer. Well, what about people who are kind of short and they have human growth hormone issues? So you might say, well, they're going to come out to be, this. You can predict somebody's going to wind up being 4'8", and you might say, well, that's fine. That's, they can live a normal, healthy life. Well, you might say, well, yeah, but if you could make them normal, say whatever normal is, 5'9", I don't know, 6 foot, wouldn't that be better? They'd be less stigmatized by their classmates, and growing up through their middle school and high school, and everybody's teasing each other, and it can be pretty brutal. And maybe they would come out better. So is that a legitimate use of that technology or not? That'll be a very interesting debate to have. What you don't want to do is try and fix someone's height and then cause a brain tumor, right? That'd be terrible. So we've got to make sure the technology is really working. I think as we fix the obvious diseases I mentioned, sickle cell, a lot of these blood diseases, we'll get the technology working better and better, so that someday we probably can make nice, clean fixes that will hopefully, if you wanted to make someone who's going to turn out abnormally short to be normal, that'd be, for me, it's fine by me. Now the question is whether you want to take somebody who's predicted to be normal and turn them into, a 7'6" giant so they can be a great basketball player. I don't know. That seems like not such a good idea, but because it probably has other health issues associated with it. And basketball, hopefully there's more to life than playing basketball. So,
well, I was actually going to ask about the ethical concerns of it, right? Because I remember in like 6th grade science, we were talking about genetic editing, and she was saying like, this is a great, everyone was saying like, oh, this is a great idea and stuff. And she's like, well, then you have the concept of more or less getting rid of like a certain type of person, right? Like, I think we all know who that sounds like, right?
Right. Yeah, it sounds like eugenics. Yeah, no, that's where it gets controversial. I don't think anybody has a problem with fixing evil diseases that are going to kill people. We're all on the right page there. Then the question is, what do you do about people whose IQ is not going to be as high? And are you bringing in other things? And some people say, well, some of these changes have been selected, which is true, to probably improve people's health. And so there is some advantage of genetic diversity out there. So sickle cell, for example, was thought to help protect people from malaria because it affects the blood cells. There'd be less propagation of the microbes that causes problems. So some of these things were probably protected. Even cystic fibrosis people have argued that in certain mild forms is actually protective against, maybe protective against certain diseases. So when you start getting rid of that, will you lose that protection someday when you need it? Will the human race lose that protection? Now, if you're the individual person with cystic fibrosis or sickle cell, you're not there to trying to save the human race. You want to save yourself. So I don't think there'll be a problem with fixing a person or fixing an adult or a child so they can live a normal, healthy life. But trying to change gene patterns is a very interesting and controversial area, as I say. But it's mostly there's certain areas, especially when it comes to enhancement traits. Like there's no good reason to be changing skin color or any of these things like that. They just don't have any real value for doing that sort of thing.
Right. Yeah. Because my thing would be, at what point does it become a little bit either silly or unnecessary? Like, do you really want a society of like only people that are 6'4"? Like, does that really make sense? Like, just because, I don't want a short kid or, like it seems.
Yeah, totally agree. Yeah. And we'll also have trouble sitting on airplanes though, with the tight seats. Yeah, no, it's nice to have genetic diversity. If we're all the same, we'd all be pretty boring.
I think I saw, or my uncle was telling me about a movie called Gattaca. It's
Yeah.
actually
Oh, yeah.
that. Yeah, where
I
yeah,
know very well.
I
One
haven't
of
seen
my
the movie.
favorite movies. Oh, you got to see it. It's really, and what's amazing is that everything you say in that movie is largely true today. So you got to see it. It's and I won't be a spoiler, but yeah, it's about a person who wants to be an astronaut, but is predicted to have a certain defect, which he's able to overcome. So So anyway, it's a very, very interesting movie. But a lot of the things they bring up in that movie are actually very valid issues, and it's still as relevant today as it was when the movie was made. I can't remember now, 25 years ago, something like that.
Right. Well, he did tell me like the basic concept, like they can basically take the best traits of both parents and then put them into one kid, and this kid is born. It's a little brother, and he has like he's born like a superhuman. Like not like no superpowers, but like just off the charts intelligence. Off the charts physical abilities. And then his older brother is like, well, I want to be an astronaut, but he's always like the weak one, so to speak. And it's about why he wants to become an astronaut and like his struggle to become one. And like as you can imagine, it wouldn't be a very fun movie if he didn't, eventually become one. But
it
yeah,
raises a lot of issues. It's really, really interesting. But then there are gray areas, right? Like narcolepsy. Narcolepsy is genetic. So people falling asleep. Do you want an airline pilot to be, narcoleptic or not? The answer is no, you don't, because you don't want them. Same with a ferry boat driver. There's a famous accident in New York where a ferry boat person fell asleep and crashed the thing into the dock and killed a bunch of people. So you don't want, now that may not have been due to narcolepsy. It could have been drinking. I'm not sure. But anyway, the point is that you don't want, you wouldn't want a narcoleptic in certain situations. So then the question is, do you have a right? Right now, you cannot be genetically discriminated against based on your genetics for employment. So you can't stop someone from doing something if they're genetically predisposed. And for the most part, that makes a lot of sense. You don't want to be discriminating against people for employment, for healthcare, things like that. But there might be a few cases where you'd like to know. But I think you can get around those cases by doing tests. Like you could see whether somebody's narcoleptic, try and figure out what the right test is without doing a genetic measurement on them. And so I think there should be workarounds in many cases to deal with that. But there might be cases where you'd like to be sure, as we say, like narcolepsy and airline pilots is just not something we want to see happen.
right. It's just a lot of ethical concerns, I would say. It's kind of like the same issue of cloning, where at what point is it just playing God? Just creating life just to create life, or changing things.
Again, for most things, it's not a big deal. Fixing people's mutations. Yeah, it's where what I like to call enhancement traits, making people taller, trying to make them smarter, as I say, whatever that means. Uh, yeah, try and make them their appearance, more pleasing to others, beauty, whatever that means. So we having those things are definitely questionable in ethics, I would argue. Yeah. So there'll have to be a lot of discussion about that. But there are a few that'll be, like I said, I mentioned height. Is it ethical to make someone go from who would clearly be too short, which you can predict, into a normal range? Is that ethical or not? I actually don't have a problem with that, but a lot of people may. I'm not saying let's make everyone 6'4". I think that's the last thing we need. But I do think taking someone who might wind up, 4'6", whatever, which you can predict these days for the most part, with reasonable accuracy by following the first few years. If you can make them more normal, that's probably not bad. And they do it now by human growth hormone injections, but it doesn't work that great.
Well, this kind of ties in both questions I've asked, which is when it comes to getting older, and when it comes to the fact that humans are unfortunately not going to live forever, right? So, number one, I've heard different things saying that humans can only live up to a maximum of like 126 years, right? Now, number one, is that entirely true? Where does that come from? Like, would you know? Or
Yeah, it turns out that in general, if you look at the longest living people, you said 126 because that's how I think it's 126, 123, but the oldest living person lived. She's a French woman. If you look up on Wikipedia, you'll see that the oldest living people, they're typically around 118, 117, and I forgot how old the oldest living person is right now. I think it's 116, 117. So they will die around very oldest living people tend to die around 120. So people say, well, that must be the lifespan of humans. I personally think people will be able to live forever, that we'll be able to re-engineer them so that your stem cells will replace a lot of your so-called wearing out parts, and you'll actually get them to live forever. Number one thing to do is keep your immune system in good shape. And that should help. Now, I'm not saying it's going to happen in my lifetime, but by the way, I think I don't know how old you are, but most people would say anybody born today should live to be 100 for sure. Unless, something bad, a car accident, something like that happens, but you should be able to keep people's health up for the most part, so they live to be a long time, because you can fix a lot of things that go wrong. You catch disease earlier. Big part of our work is that way. I think the key is to keep catch cancer early and keep it at bay. That's going to be a tricky one. But the reality is we are getting better at this stuff. Most people die, you may know, of two things, either cardiovascular disease or cancer. And we're better at catching those things and fixing those things. So I think most people think we will live longer. I will live to at least be 100. And you're right. But a lot of people say, well, then and it's true that they'll peter out at 120. I personally think if you replace it, as I say, you should be able to get people to live forever, but that's going to take a lot more work. One of the most serious issues about this longevity stuff is the brain. You don't really it's not really just living forever, it's their health span, right? You want people as healthy as long as possible. You don't want them getting dementia at age 80 and then hanging on for 40 years as a vegetable. That's not going to be very useful to them or fulfilling to them or their loved ones. So just the opposite, it's probably going to be a drain. So having people's health span peter out is not good. So we want everybody to live, healthy, and then just die right away. That would be ideal. And the brain will be very tricky. I think keeping people's cognition up. And you probably know, I don't know if you know, I know someone who's 100 years old and he's sharp as a tack. He's still amazing, right? And then you meet other people when they hit their 70s or even earlier, and they're having trouble. So keeping your brain in good shape, that's something we really don't know how to do. People are working on it hard, getting to be, I think if you want some simple things that I believe in, it's good nutrients. I wish I knew when I was your age what I know now, but Antioxidants is a big deal, anti-inflammatories, something called nitric oxide that actually is good for your endothelial cells, keeps your blood flow good. That's all important for your health and your brain in particular. So I think there are things you could do now with nutrition that will very much help you live a long, healthy life. And I wish I had known, as I say, and started on some of that stuff earlier. I take about a dozen supplements every day to keep try and keep my health up.
Well, that actually, I want to ask a question about diseases like dementia. So like for me, for example, right, my grandfather had Parkinson's, and my grandma, who's still alive, currently suffers from dementia. So, you know, is my risk of, neurological diseases like higher? And if so, like what's the best thing I could do, like long term for that?
Well, yeah, exercise number one. So first of all, I don't know when they got it. If they got an early age, that is concerning because there's probably a strong genetic component to it. Okay.
It was more like their 70s, 80s.
All right.
So it wasn't really.
Yeah, but if it happens early, you worry there are certain genes that have been identified for, like Parkinson's and dementia things. And there you can actually measure. There are tests for that sort of stuff, for at least some of the genes that are involved. So that is addressable. Well, you can't do anything about it, even if you find out what's going on. But what you can do now, so the fact they live pretty long without getting this, yes, you are at risk when you hit that age. What can you do about it? Well, I would argue some of the things I just mentioned, this nitric oxide stuff is, we think, a big deal for it keeps your blood flow up, and your blood-brain barrier requires all these micro blood vessels that help supply your brain and your whole body with blood. So keeping those in good shape. So try that. Believe it or not, that comes from a beetroot extract. Although you can get supplements, that's one I do take. I have no financial conflicts here, but I would argue antioxidants is a big deal. Your mitochondria go off over time. It's why you lose energy. You gradually accumulate genetic mutations in your mitochondria. And so you accumulate genetic mutations because your mitochondria make all these reactive oxygens, and your antioxidants help reduce that. So I would keep up on your antioxidants, your anti-inflammatories, things like blueberries and strawberries are good for antioxidants. So it's just a paper out saying strawberries are really great for improving cognition, keeping people sharp into their later years, reducing dementia. So eat your strawberries and blueberries. They're loaded with them. And I'm a big believer. We're a big believer in fiber. Here I am, Conflict in my lab does a lot of this. I have a company called January AI that sells something called Edens. It's a combination of fiber. So most people don't get enough fiber. I don't know if you know this, but women should have 25 grams a day, men 35. And the average person has 10 to 15, not even close to what we should be having. So that's important for your gut, which is important for your immune health, and makes a lot of these things that are important for your brain as well. So we think having enough fiber, and so they have a product called Edens that has fiber plus some of the microbes that eat the bacteria. They're called probiotics, and also something called polyphenols, which are antioxidants that we think is good for your gut health and good for your overall health, and seems to be, from the various tests we've done so far, looks very encouraging. So we think those kind of things. So I would say get your fiber, get your antioxidants, anti-inflammatories, nitric oxide, and then keep up on the other things too. Most people are deficient in vitamin D. Omega-3s are good for you. Have you heard of those? They're important for your brain as well. So you keep up on your omega-3s, fish oil, and other forms of supplements and things can give you those. So there's a number of things you could do. And as I say, I wish I'd started that early in life. I've been doing it now for a few years anyway.
So, and this is part of the fitness part of it with aging, and mental health and exercise. When it comes to weightlifting, what is some of your, weightlifting? Do you have any weightlifting advice, or like on how to build muscle, maybe, because you mentioned how that would be important, like long
Right.
term building muscle. How could I gain as much muscle as I could and get as strong as I could?
Yeah, well, it's not just gain muscle. So some people do it by steroids. That's actually probably not necessarily the best way because it doesn't give you good fiber packing and stuff. So I train with a group of people called they're Happy Body folks. They're actually Polish weightlifters. They're world champions, and they taught me this, and people can search them out if they want. Look them online. Happy Body. They work with you. They do light days and heavy days because you probably know you can't just do every day heavy weightlifting because that'll actually overstrain your muscles. So I do light days where I do many more reps, and then heavy days where I'm pushing myself with a lot more weights but fewer reps. And that balance seems to work pretty well. It's a myriad of different exercises. So I have 18 different exercises I do with different reps to be able to try and cover as many muscles as possible. And in particular, as you get older, people want to keep their spine in good shape. But you probably notice a lot of old people, right? They start hunching over. They get their osteoporosis, and also keeping your shoulders in good shape. So a lot of the exercises I do are actually very much built around that. So squats, and believe it or not, I do a lot of snatches. That builds your core. And that's a big deal because, again, that really is good for your spine and your shoulders. So those are the things I think you can do when you get older, but you can't just walk right up and do it or you pull a muscle. That's not good. So make sure you get the proper coaching when you do this so that you don't hurt yourself. And in my case, I have had sore shoulders from actually softball of all things. And so I need my weightlifting to get that back in balance. But I haven't really injured myself with weightlifting, in part because I think I have a pretty good balance of things I do. And so, I'm a big believer in all of this, again, for keeping your strength up and trying to stay healthy for a long, long time. Just to emphasize something I said earlier, when people lose muscle mass, as soon as they become immobile, that's it. Their health just plummets. And also when people get really old, like when people turn 80 and everybody says, oh, just take it easy. That's actually bad advice. No, get out of your wheelchair and start walking around because that's actually good advice. Try and keep people moving is a big, big deal when they're older. And there are plenty of studies now that show that as you get older, exercise is even more important. So if for anyone listening, get up off your couch and get out there doing stuff. And I'm a big believer in strength training, and resistance training.
I have two final questions, and this one is actually basically just related to what we were saying. And I feel like I know what you're going to say, but in terms of what's the best health advice for people that you would give, what would it be?
Well, I'll say the standard stuff that you're going to guess, which is exercise, number one, eat well, but eating well is complicated. And the third will be get enough sleep. Make sure that you're supposed to really get, which I don't do, but you're supposed to get 7-8 hours sleep. It probably varies a little bit with different people, but as you get older, you'll see people will shorten it to 5, even less. And so you should do that. I'd say on top of that, though, there's a lot more in today's world you can do. I'm a big believer in these, if you've ever heard of them, continuous glucose monitors, the little patch you put here. You can see what your glucose control is now that you've never been able to do before. And that's a big deal because we didn't talk about this, but 9% of people are diabetic, 33% of people are pre-diabetic, and those numbers in the US, and those numbers are getting higher and higher. We are hitting a diabetes endemic that's worse than the COVID pandemic. And so getting your glucose under control is a big deal. And so these new continuous glucose monitors are really powerful because they show you what foods spike you, which ones don't. And that varies from one person to the next. So the foods that spike you, George, are going to be the foods that are different from the foods that spike me. And once you understand what foods spike you, meaning your glucose goes out of whack, you can avoid those. You can really change your diet. So you can use modern tools to find the right nutrition that's best for you. Once again, I have a company for this. It's called January AI. Here I am conflicted. That teaches people how to eat better so that they don't spike their glucose. We think that's a big deal. So use modern tools. And I mentioned a smartwatch for disease detection. There's a lot of stuff we can do now that you couldn't do 5 years ago, 10 years ago. So we think this is with you can use the modern world to help you behave better, even with old techniques like eating.
That's good. So, I mean, would you recommend fasting at all? A lot of people say fasting is really good.
That's becoming a big deal. Yeah, we're running some studies there now. There's a lot of studies. It's called time restricted eating. Try to eat within an 8-hour window. Don't eat all day long, and definitely don't eat before you go to sleep. That'll keep you up. Your glucose will be high the next day. So not only what you eat, but when you eat is a big deal. Yeah. This time restricted eating, try to keep yourself eating in a very defined window will help.
Now, for the last question, a new one came into my head too. But it was, what's the most important thing you've learned about the human body in your research?
Oh, that was just pretty complicated. But we're also very dynamic, interactive system. Meaning, if you have to keep everything tuned properly, just like your car. If you have something that goes off, the whole car doesn't run right. So I would say try to keep your body very tuned, especially around metabolic health, metabolic control, and then your immune system will work well. Everything should work well. So I think that's probably that we are a very intricate, well-oiled machine, so to speak, and you want to keep that running well.
And for the last question, what is the most meaningful thing you find about your research?
Well, I hope that we're able to help others. I really do want to transform the way we manage health. Like I said at the outset, that is to say, I really want people who live, everybody's going to live to be 100, as I say, is born now, or unless certain things happen, but and that they should live healthy that whole time, right? That's the goal. And I think the things we're trying to do about health monitoring, health tracking, advice we give people will help them do that. And my lab happens to spin off a lot of companies that, again, try to get the things we're doing out to the world. It's not necessarily to make money. It's really just to try to get the kinds of things that we discover in the lab out so that everybody can benefit. And I hope that'll be true. And yeah, I've even written a book that I don't make any money off. It's dirt cheap. And it's just meant, again, to educate people. So that's how I hope we'll have impact.
All right, that was good. All right, I'm going to talk to you a little bit after the show. All right, is there any closing words you have?
No, it's been great to be here. Thanks so much for having me.
No problem. Come back anytime. All right.